see a show of hands of who has seen An Inconvenient Truth by Al Gore. All right, that's pretty good number of hands. Well, my slides aren't nearly as good as the vice president's, but I hope we can cover some of the same topics and maybe help you understand some of the science and the impacts of global warming a little bit better. So first, we got to talk about the greenhouse effect. So the greenhouse effect, you've probably heard this term, but really it derives from the ability of greenhouse gases, primarily carbon dioxide, also methane, and some other industrial gases that we humans have been creative enough to create. And they're up there in the atmosphere. The sun shines down, hits the earth, and radiates back out heat. And there's this blanket of greenhouse gases up in our atmosphere that traps some of that heat, that helps keep the world temperate, helps us have agriculture, helps us have many of the important things we have on this earth that wouldn't be here if we didn't have this blanket of greenhouse gases. But from human activities, from burning fossil fuels, from cutting down forests, we're adding to this blanket. So we can think of our emissions of greenhouse gases as thickening this blanket around the globe. And if you can think about in winter, when it's a little bit colder, you put on a heavier blanket to stay warmer. That's what we're doing in some of our activities. And we know it's real, and we know differences in it have a big impact just by looking at our solar system, our neighbors. So if you go to Venus, which is a little bit closer to the sun, but not all that much, and it has almost 100%, well not near, about 96% carbon dioxide in its atmosphere, and the surface temperature is so hot it would melt lead. So that's a little too much greenhouse effect. That's pretty uncomfortable. Then we have our Earth, which actually only has a pretty small fraction of carbon dioxide compared to the rest of the gases in the atmosphere, but it's a really crucial amount that keeps us, as I've said, habitable for life, and that we're adding to that percentage. And then you can look a little further back, a little further from the sun. You have Mars with almost no carbon dioxide except frozen in the poles and in some of the ground, and it's really cold. And maybe there was life there someday, at one point, and maybe there's still some deep in the ground. That's what NASA's working on figuring out, but definitely not life as we know it. So an important part of keeping carbon dioxide in the atmosphere is the global carbon cycle. And so any molecule of carbon is incorporated in this cycle, whether it's as a gas like carbon dioxide, whether it's in plant matter like wood, whether it's in your own cells. It's the integral part of life on this earth. And you can see in this slide of the carbon cycle, we have exchanges from carbon in the atmosphere into the deep ocean, from the atmosphere into plants. And this cycle in the past has created some important things. It's created coal, it's created oil and gas. And what we're doing right now, since the Industrial Revolution and our discovery of the use of these fossil fuels, is we're basically liberating ancient carbon and putting it back up here in the atmosphere, and we're swamping the ability of our ocean atmospheric carbon cycle and our atmospheric land carbon cycle to contain all of that carbon. And so that's why we're having an increasing amount of carbon in the atmosphere and also in the oceans, which has other impacts as well. So we know that carbon dioxide has varied in the past. This is a chart of carbon dioxide from ice cores. And you can see this is kind of today. This goes back 400,000 years. So there have been ups and downs for sure. And we'll talk a little bit about that. But you can see here, we are way off the charts from what kind of natural impacts in the past. And this is just a close-up of this. You can see it was going pretty flat, pretty flat. Here's the Industrial Revolution, roughly. And then we've just taken off, and especially in the last few decades. So one reason those squiggles way in the past were actually because the orbit of the Earth and the way we rotate around the Earth is not quite perfect circles. So that adds slight changes in the amount of sun, which leads to big impacts like 2 miles of ice sheet covering, large parts of North America. Not down here in Florida, but through the middle of the country and north. And it had big impacts on Florida with all that water locked up on land. There was a lot more to Florida than there is right now. And you can see if you put in, I'm a chemist, so I stayed away from the math as much as I could, but those of you who are good at math and physics, you can take some of these changes in the orbit and figure out how they impact. And pretty much if you add all those top 4 squiggles together, you get something that's supposed to look like this last squiggle, which is what we see in the historic record in ice cores, in ocean sediment cores, in a whole bunch of geologic records. Now what we see right now, so if you can, this is just back in 1960, so a blink of the eye in the geologic record. This is carbon dioxide in the atmosphere as measured out in the middle of the Pacific Ocean. And you can see it just is going up and up and up. These little squiggles deal with seasonal changes to the growth pattern of plants, since plants suck in carbon dioxide. But you can just see here, straight up trajectory. Whoops. And we know where those, if you remember back to that carbon cycle, and I said we're liberating ancient carbon, that's all coming predominantly from burning fossil fuels. And you can see right here, this is the total amount of carbon emissions from fossil fuels. And here you can see coal starting back here in the Industrial Revolution. That's what we mostly started with. Then we found oil early on here, but we really found the Middle East deposits and some of the bigger deposits in the world back here in post-World War II. And now you can see that actually petroleum, oil products, and mostly for fuel, are really the top emitters of greenhouse gases compared to coal. We've also ramped up on natural gas, and cement production is a big contributor as well. And so we know all this carbon dioxide is going into the atmosphere, and we know our blanket on the globe is getting thicker. So the question is, what happens to global temperature? And not surprisingly, global temperature has been rising. So again, this goes back to about when we started to have records of temperatures on the land, so around the time of our Civil War. And you can see again, it's just, it jumps around a little here, but especially in the last few decades, it's just going straight up and matching sort of what we see in the carbon dioxide record. And so if you look at what has already happened to warming of the Earth, you can see that we're getting warmer in most places, and especially in some critical areas in the northern and very southern latitudes. So in the Arctic and the Antarctic, we're seeing parts really warming up, and through here in Siberia. So we know that we're warming. But why are we warming? Because I showed you we've had ice ages. That was definitely the cavemen weren't burning a lot of fossil fuels, and we had ice ages before we really even had man. So the question is, how do we know we're impacting it? And the answer is pretty clear that we are. And here's one of my favorite slides for understanding that. If you look at the red line, that's what we know has happened in temperature. That's what we've been able to measure for the past 150 years. But we understand how our orbit of the Earth changes. We understand what natural impacts should do to our climate on Earth. So that's in this first slide, that's what this blue is. And you can see some places it matches up all right, but especially in this last part, it's not matching very well. We also know what we humans have done to influence the climate in this time period. And you can see, again, some places it matches, not totally in others, but it's getting closer, especially in this last period. But when you add these together, when you add the natural and human impacts, you get a match that's pretty darn close to what we've observed. So it's our impact in concert with natural variation that's really driving it. And just to bring home this last part here, you can see most recently, we humans are basically taking over as the major impact on what the Earth's climate is. And that's a pretty significant thing and hard to get to grips with, but there's 6 billion of us on this earth now, and we do a lot of things in our daily lives that impact and that create greenhouse gas emissions. So this is some prediction of what could happen if we don't do anything to change. This is sort of, we just kept going at the rate we've been going. These are some predictions of temperature rise that we might see. And this is in Celsius, so you can just kind of double it to get an idea of what it might be in Fahrenheit, which is what we're more comfortable with here in the US. But you can see it gets warm. And this is in 2070. So I might still be around in 2070, but many of you in this audience, you definitely will be. And so when we think about these impacts as future impacts, they're your future. They're the impacts that you may experience in your lifetime. And some of this, warming to this degree is really going to be catastrophic. Not only do we have the upper latitudes really warmed, Africa is going to suffer incredibly. And this area right here is better known as the Amazon rainforest. And temperature increase there would mean probably the loss of a large portion of that. And it is a key for weather as well as agriculture and moderating the Earth's climate there. So here's a little chart that goes over some of the risks associated with climate change. So in 2050, and I know this is maybe hard for you to really grasp. I know 10, 15 years ago, when I was about the age of most of the people in the audience, I had a hard time getting to grips with what life would be like when I was the ancient age of 32, which is what I am now. So I know it's kind of hard to get to grips with what you're going to be like, what the world is going to be like when you're 60, 70 years old. But there are some serious consequences that you all could face, and that we as policymakers and influencers right now need to make sure we ensure that we give you the best chance possible to live and deal with these changes as we can. And so, here's just, let's see, risks to unique and threatened systems like the Amazon rainforest, extreme climate events like storms, hurricanes will be increasing. Various economic and ecological impact is down here. It might get a little bit better before it gets worse, but in some places, but it's mostly going to be negative for most people. And then there's risk of irreversible large-scale and abrupt transitions. That's the things, if you saw like The Day After Tomorrow, that movie where the ocean conveyor belt shutting down. Now, it's not going to be quite like that, but there won't be, freezing storms coming down from the upper atmosphere, but things of that nature, losing the the Greenland ice sheet can be significant, and we can't fix that. We know large sheets of ice are melting all around the world. This is from the Larsen B ice shelf in Antarctica. And this ice sheet, which is the size of Rhode Island, collapsed in a matter of weeks, faster than any of the glaciologists ever thought it could. And that was a real wake-up call that we actually don't understand the dynamics of ice sheets very well, and we could lose them a lot more quickly than we thought. This is just a map of where glaciers all around the world are thinning. Now, the blue means some of them are gaining, and that's not unexpected because precipitation increases, rain increases in some parts because of global warming. But for the most part, they are thinning, and thinning in critical places. So Greenland here is losing ice rapidly, and that has consequences for global sea level rise. The Western South America, which is dependent on glaciers for power, for water, their glaciers are going very quickly. Here, the Himalayan plateau, again, I think it's over 2 billion people get their drinking water from glaciers on the Himalayan plateau that are rapidly going away. And so we're seeing drought stress, but also electricity problems here who are depending on hydropower as this clean energy, but if your glaciers go away, you don't have a source for that water. And we're seeing it also in the West, both from glaciers, but just western snowpack is going to be a critical test to Western America as we continue to warm. Now, if all those glaciers on land melt, the sea level is going to rise. Now, this is this one you probably don't have to worry about in your lifetime, but maybe your kid's lifetime. If all of Greenland were to melt, sometime as early as 2100, we could have sea level rise up to 6 meters, which is about 20 feet. And you can see what that does to Florida. It radically changes the geography of Florida. Forget going to the Keys in Miami. Orlando might need to move a little bit north or south there to get onto some high land. But it dramatically changes the state. And even before this severe of impact, you're going to have challenges with fresh water. A lot of your fresh water is in aquifers, and so as sea level rises, it moves into those aquifers and provides a challenge there. It makes that water undrinkable. So there's a lot of challenges with sea level rising even before it gets to this level. If you can think of, if you'll remember back to the hurricane season of 2005, which was pretty wild and crazy, more as sea level rises, more hurricanes, even of less severe strength, cause more impacts. But predictions are that global warming will increase the intensity of those storms. And we're already starting to see some of the data that says we're already seeing this increase in severity. So seasons like the 2005 hurricane season could become normal. And that's a big challenge to coastal America. So where are these emissions coming from? You can see on this chart that the U.S. and Canada are the big emitters, but some of our friends abroad are gaining quickly. I think the good piece of news here is to look at Western Europe, which is this kind of red curve here, and you can see that they went up pretty quickly, but they've actually in the past couple of decades managed to plateau. So that gives me hope. That means we can figure out ways to power our system, to have vibrant democracies, to have vibrant economies without increasing our emissions. So that's got to be our goal going forward. And here are just the world's 20 largest populations, looking at fossil fuel usage per capita, and you can see that the United States is by far and away the largest emitter, the largest user of fossil fuel per capita. And someone just fainted, I think, on learning that. So to put that in perspective, here's the United States, and here's where these emissions of these states equal other countries. So China makes up most of the emissions coming out of the east, but you can see the United Kingdom is about equal to what we emit from these western states, Brazil, kind of the Rocky Mountain heartland there, Russia is sort of the southeast. But you can see how we stack up here. And this is a real challenge for us internationally. That's why so many countries have said, the United States really needs to act before we act. And I think we're on the road to taking that action. And that will bring other countries along with us. Oops, sorry, I'm doing. So Nikki's going to get into the policy here, so don't look at the bill names here. But what I put this slide up for is to show you the challenge that we're facing to reduce our emissions. So here's sort of, if we just forgot about it, we're just going to burn fossil fuels like there's no tomorrow. And if we did, there probably wouldn't be. We'd be going up, we'd be going up this line. And what scientists tell us to stabilize at 450 to 550 parts per million carbon dioxide, and we're already at 380, that's what we need to do to avoid dangerous climate change. And that's what this gray shading is. So you can see from this business as usual to getting to here, that's a big difference. And that's the challenge we face. That's what some of the other panelists on the next panel especially are going to talk about meeting. And we have ways we can do this. This is definitely achievable. But again, this is in 2050, so I'll be 76. You guys will be running the world. You and your younger brothers and sisters. So my goal as a person involved with policymaking now is to work my hardest right now to make it possible for you to run the world effectively and safely and sustainably out here. And just because of that urgency, Speaker Pelosi is the new Speaker of the House of Representatives, established the Select Committee on Energy Independence and Global Warming, and we're just a few weeks old, so this will be our website, but it's really not quite ready yet. So check back in a week or so, and hopefully we'll be there. And you can follow along with the hearings and the work that we're going to do for this entire Congress, and I hope you'll join us. We want to have a lot of activity with young people on as well as online as well. And this is my boss, Chairman Ed Markey. And what our instructions are from the Speaker really are to come up with policies to generate reasons to take action that reduce global warming pollution, reduce our oil imports, and to create the new jobs and industries of the future. Your generation is going to be the green generation. And I keep seeing statistics about how many students now want to study sustainable energy, sustainable design. And we have to, just as we sort of unleashed the power of the internet and created all the jobs and industries that came out of that, we have to do the same thing for energy. And that's what we're trying to help set that stage at the Select Committee to do that. And just to preview a little bit what the next panel will talk about, I guess, and to wrap up, I just want you to look at U.S. oil production and imports. So production has peaked back in the early 70s, but our needs have continued to grow, and so our imports have just increased. And just as an example of one of the policies we know that can deal with oil imports as well as reducing global greenhouse gases is something called CAFE, Corporate Average Fuel Economy, which puts a requirement on the auto industry to produce efficient vehicles. You can see here that we dramatically increase the efficiency of our vehicles in the late 70s and early 80s, and then we've kind of plateaued. So really to tackle global warming, to tackle our energy dependence, and frankly to revive Detroit, we need to increase the fuel economy of our vehicles. That's one of the things you can do as people who may be getting cars soon, who influence the car buying decision in your families, is to advocate for getting the most efficient vehicle you can, maybe some of the new technology, use some of the new fuels. But that's just one small thing that you as individuals can do because, as I say, this is your future, and there's going to be a lot of talk on Capitol Hill about future impacts, but all of these are going to be happening to you, and that's one reason your moral authority as youth and as the generation that's going to inherit this world needs to be heard, needs to let legislators know that you care about this issue, that you want to see them create ways for you to have new and exciting jobs, for you to be able to have an environmentally sustainable world to live in, and that we can do it. I think most of your generation feel we can, that there isn't a trade-off between economics and the environment, that we have to figure out how to do both. And that's my charge in the next year and a half that I work for the Select Committee, and I'm looking forward to doing it, and I'm looking forward to your help as well. Thanks.
Thank you very much.
I am so sorry to tell you this, but this is not the last time in your life you're going to be dealing with stress about things that have real consequences. Some of you already know that, of course. Some of you have experienced some serious health situations, family crises. Some of you have friends in Iraq, no doubt, and or maybe some of you have even come back from Iraq yourself, and there's going to be more of that. But by the time you're my age, and as Anna says, it's kind of hard it's hard when you're in your late teens and early 20s to really know or care what it's going to be like when you're in your 30s or 40s. But you get there very quickly, and by the time you're our age, and maybe even sooner, climate change will likely be a predominant source of stress in your life. Either the impacts of climate change or the things that we're going to have to do to keep climate change from getting worse. And it'll have effects on where you choose to buy a house, what job you choose to do, your hopes and fears for your kids. It'll have effects on our national security and effects on our economy. But like all the challenges, sort of like the college thing that I mentioned, we're going to deal with it together. We're going to still be in the workforce for a little while longer. You're going to be coming out very quickly. We'll work together on this thing. And we'll get perspective on the problem. We're going to celebrate the minor victories. We're going to have faith that we're going to have the major victories. We'll laugh where we can. We'll continue to love each other and all that, and we'll move on. Now, why the heck am I telling you this? This is supposed to be about the politics of climate change, right? The reason I'm telling you all this is because Anna had all these really great pictures to show. I don't have any pictures. I'm about to talk to you about what's going to feel like really inside baseball. And what pictures would I show you? Lou's a good-looking guy. Anna's nice-looking, but most of Washington looks like me. Washington is Hollywood for the ugly, And so what am I going to do? Show you pictures of guys like me? No, it's going to be mostly words. But who here is following March Madness? Are you following March Madness? It's gotten sort of uninteresting. Duke is out, Georgetown's out. I barely even know who's in anymore, right? Oh yeah, sorry, yeah, right, Gators, right, sorry. But believe it or not, and I know you're not going to believe it or not, politics, aside from the fact that it's Hollywood for the ugly, and also because there are a lot of people who try really hard to keep you from knowing exactly what's going on behind the veil of PR that they put out. Once you figure out what's sort of going on behind that, politics is actually as interesting and as weird. There are as many twists and turns. There's much intrigue. There are grown-ups, smart, highly paid grown-ups doing ridiculous, stupid, crazy things. There are also people doing very heroic things, and it's as interesting as any March Madness. I guarantee. You don't believe it, I know, but I guarantee. And most importantly, politics and the public debate. That's how we are all going to solve. We're going to address this problem. That is the means by the way we're going to address this problem. So what I'm going to do now is give you, and I'll try and make this relatively painless, a little bit of an introduction to the politics of climate change. First, I'm going to tell you a little bit about who the Pew Center is. I'm going to take you through quickly through the U.S. debate on climate action to date. We're going to do a quick 101 on climate policy, and then we're going to look into the policy crystal ball. First, who's the Pew Center? We were founded in 1998. We're nonpartisan, nonprofit. We put out all this great research on climate science, climate economics, policy, that sort of thing. I think most interestingly, we have an advisory committee of 42 major multinational corporations. We don't take money from these folks. We don't speak with them in a formal way, but we try and keep very closely in touch with them. And you will hear it said a lot of times that this is a struggle between the environment and the economy. And that's not true. And what these companies feel is that we know enough about the science of climate to act now, and we can grow the economy and address this problem together. And so a little bit about the federal action to date. And in 1992, around the time most of you were born, George, which is scary as hell to me, the first George Bush, pardon my French, the first George Bush supported something called the United Nations Framework Convention on Climate Change. This is a global international treaty that basically said climate change is a serious problem, we need to do something about it. The Senate quickly ratified it. We were the third country in the world to ratify this treaty. It was really the high watermark. So the high watermark of federal action on climate change happened around the time you were born. That is pathetic. The objective of that treaty was that we needed to stabilize greenhouse gas concentrations in the atmosphere at a level that would prevent dangerous anthropogenic interference with the climate system. In English, we needed to stabilize the concentrations so that we don't have dangerous climate change. Some would argue, looking at Anna's presentation, which by the way is all very strongly backed up by all peer-reviewed science, but by the predominance of peer-reviewed science, we're probably crossing that threshold now already. But the Framework Convention said we're going to do this voluntarily. And so the first Bush, Clinton, and the second Bush launched and expanded voluntary programs, and not too hard to predict, there were some good voluntary reductions done, but emissions continued to rise. About 1% per year. In 1997, the Senate passed a resolution saying the United States is not going to become part of a global treaty that mandatorily caps greenhouse gas emissions unless we get India and China to do the same thing. And unfortunately, the Senate voted 95-0 in support of that idea. And then, despite that very strong Senate statement against a treaty like that, the Clinton administration went to the conference at Kyoto. Who here has heard about the Kyoto Protocol? Have you heard about it? Okay. So the Clinton administration went to the conference in Kyoto and supported the Kyoto Protocol, which basically was in opposition to this Byrd-Hagel resolution. But rather than come back and explain why they had done something that was completely opposed to where the Senate was, President Clinton unfortunately backed off. And then in 2000, and the reason I say that is because it's sort of easy to say all our problems rest at the feet of the current administration, but it's not accurate. We're in a hole. The hole is a bipartisan hole, and we're going to need to dig out of it in a bipartisan way. In 2001, the current President George Bush repudiated the Kyoto Protocol, essentially disengaged the United States from any serious negotiation in an international treaty. And he had made, during the campaign, he'd made a promise to cap carbon dioxide emissions from power plants. He broke that campaign promise. But then just sort of ticking through some of the other milestones, Senators McCain and Lieberman, I'm sure you've heard those names. McCain and Lieberman in 2003 introduced a bill to cap and trade greenhouse gas emissions. They got a good debut vote on it. And then in 2005, the Senate passed a non-binding resolution that said, okay, we're not ready to say how we're going to do this, but we are ready to say that we need a national mandatory program to reduce greenhouse gas emissions. And then from 2005 to 2006, lots of stuff has been happening in the states. Actually, I think one of the most exciting recent developments is that your own governor has recently said that Florida needs to get serious about this issue. That's very exciting. That's actually a change from the previous administration, and it's a huge step forward. If you look back at the history of U.S. environmental law, it's typically the case that the states are in the lead. There's a few leading states, and that the federal laws are sort of based on the foundation that is poured by the states. And so Governor Schwarzenegger, you all know Arnold, right? So Governor Schwarzenegger in 2005 basically set out this incredibly ambitious program of greenhouse gas reductions. He said that we need to cut our emissions by 80% by 2050, which is extremely ambitious. And the California legislature backed him up. And then in the Northeast, we had a bunch of states that said they were going to cap their CO2 emissions from power plants. And in 2006, we basically had Congress. We had some leading people in Congress follow suit, and with that same idea. Okay, so now let me do the climate change 101, the policy 101. Here's if you're going to remember anything about climate policy from this talk. Here's what you need to know about cap and trade. Has anybody heard the term cap and trade? This is a phrase that's familiar. Okay, it is familiar to a few people. Here's basically how it works. The cap means we're capping greenhouse gas emissions from the economy. That every year we allow only a certain amount of greenhouse gas emissions from the economy. And the trade means basically that we allow trading between companies to decide who's going to do those emissions. So how does that work? Okay, here's how it works. Say EPA at the beginning of every year prints up a stack of paper. Each piece of paper entitles the bearer to emit 1 ton of greenhouse gases in the atmosphere. And by the way, this stack of paper is the cap, right? I mean, there's only a certain amount of pieces of paper in this pad, and that is the cap of emissions on the U.S. economy. So then EPA hands out the different pieces of paper to different people. Say I run a company, okay? EPA hands me 90 pieces of paper. So now I can emit 90 tons of greenhouse gases. I go back to my engineers. I say, hey, ladies and gentlemen, we have 90 pieces of paper. We can do 90 tons this year. My engineers do all these calculations. They come back to me and they say, well, we were going to emit 100 tons this year, but we can bring that down to 90 tons at an average cost of $5 a ton. We also have these other great projects. We can actually bring it down to 80 tons for an average cost of $20 a ton. So now I'm the manager. I know what I need to know. You all are running companies. You all have engineers who've told you similar things, different cost numbers, right? But we all have different capabilities. We all have different engineers. So now I go out into this market. By the way, the market would be about 10,000 companies nationwide. And in this market, if I find somebody out there who's willing to sell me tons at $3 a ton, I'll tell my engineers, okay, cool it, guys. We're gonna buy our tons this year. We're gonna buy the extra 10 tons that we need to get to 100 this year. If I find somebody out there, on the other hand, willing to buy tons for $25 a ton, I'll say, fire up those reductions. We got a customer. That's all cap and trade is. It is a way of letting the government decide what the environmental goal is, and letting the economy, letting the industry and the inventors and the investors out there figure out how to meet that goal. And it is a way of getting people who never cared about the environment before, but who care about, but who are interested in inventing stuff, who care about getting rich, to solve this huge environmental problem that we have. So a couple other things. So now if you need to know two things, you can know two things about climate policy. The second thing is about coal. We have a huge challenge with coal. About 24% of U.S. greenhouse gas emissions come from coal-fired electricity. And basically they take a bunch of coal, they grind it up, they burn it, they use that to heat water, and it drives steam turbines, and those turbines generate moved electric generators, and we get electricity from them. We got tons of coal. We're going to use it. And even if we didn't use it, India and China would use it. So what we really need to do here is figure out the technologies to use it as efficiently as possible, and then to capture the carbon dioxide emissions that come off from the combustion of the coal and put it underground. We don't have these technologies at commercial scale now. We have them at small scale, but we don't have them yet. And one of the reasons that we need a cap and trade program is so that the people who can invent those technologies will make money doing that, and then they'll get all excited about doing that. Cars and trucks. That's probably our other biggest single issue. Anna talked about this a little bit. 20% of U.S. greenhouse gas emissions come from cars and trucks. This is a three-part problem, and it's a very complicated problem. It's a very complicated problem. We need to work on vehicle efficiency. We need to get fuels to be lower carbon fuels, and we need to reduce vehicle miles traveled. What does vehicle miles traveled mean? That means how much you and I drive. And that's tough because, I love to drive. I rented, as Lou and some of the other panelists know, I live in Washington, and I flew down yesterday, and I rented this beautiful little Mazda Miata, and I went for a drive to Cape Canaveral just to see it. I love to drive. This is going to be a very hard habit for me to break. It's going to be a hard habit for us all to break. Okay, so now let me talk about the recent. I took you sort of through a quick tour up through 2006. So a lot of stuff happened since the November elections. Of course, the Democrats took Congress. That was a huge change, but it didn't mean that we necessarily had guaranteed votes for climate legislation. What changed, as it says on the bottom here, is that control of the agenda went from it went from Republicans to Democrats. That's not always a good thing, but in this case, it worked out. Among other things, Senator Barbara Boxer is now the chairman of the Senate Environment and Public Works Committee. If you're going to remember two things about the politics of climate change, remember that the Senate has an Environment and Public Works Committee, and the House has an Energy and Commerce Committee. These are basically the engine rooms of climate policy development in Congress. And with apologies to Anna, who works for another committee. Sorry. Okay. So,
is on that committee too.
yeah, that's right. Mr. Markey is on the Energy and Commerce Committee as well. And the Senate Environment Committee until last year, had been chaired by a guy named James Inhofe from Oklahoma. There are many admirable qualities to Senator Inhofe, but among other things, he likes to think that climate change is a hoax. And he has constantly said that climate change is the greatest hoax ever perpetrated on the American people. There's really no scientific basis for that, so it made it very hard to have a rational discussion about that issue. Barbara Boxer, on the other hand, is recognizes climate change for the priority it is. Senator Jeff Bingaman of New Mexico took over the Senate Energy Committee, and Senator Harry Reid, who is supportive of the McCain bill, among others, started controlling the agenda of the Senate. Nancy Pelosi, as Anna said, whatever else you may think about her, she has made climate change a top priority. By, among other things, by creating the Markey Committee. I think very dramatically, John Dingel, who's a guy who for 50 years has represented Detroit, Michigan, and the car industry, is now saying he wants a climate change law as well. And John McCain, this is less true now than when I first wrote this slide, but John McCain is at least among the leaders in the contest for Republican nomination. And there's very importantly, there's a growing sense in industry that climate action is inevitable. It's because of what the states are doing, what the EU is doing. There's huge pressure from the U.S. public. I'll skip this, even though it's extremely important. And then there's it feels to me like there's a growing, we're on the verge of a public opinion firestorm on this issue. Again, if you look back at the history of U.S. environmental law, there have been events that have sort of catalyzed the public sense of urgency on the issue. For those of you who have studied the environment at all, Love Canal, Bhopal, the burning of the Cuyahoga River. We actually had a river in Ohio that caught on fire. That sort of had a bracing effect. And so my sense is that we might be heading towards such a public opinion firestorm at this point. The science, the polar bears, Katrina, what the states are doing, the vice president's movie, the mention by the president in the State of the Union, and all these things I think are going to add up.
Your slides talk a lot about CO2 emissions, but has anybody ever looked at the methane pockets at the bottom of the ocean and the increasing temperature of the ocean and that effect on the release of the methane? Because it seems like that could really turn into a snowball effect and really make those predictions come true a lot sooner.
Yeah, there are even scarier things about the climate system than I mentioned, and methane hydrates, which is one of the things you're asking about, is one of those, is that deep in the ocean, but also in the northern tundra, there's methane trapped in the soil, in ocean sediments. Now, methane is an important greenhouse gas. In fact, it's a more potent greenhouse gas than carbon dioxide. We just emit so much carbon dioxide that it's the major gas. But if we, as temperatures continue to warm in the Arctic, especially, we are in danger of releasing that methane from the land and from the Arctic Ocean, especially, and having a major and dramatic kind of negative feedback loop, which would mean we would warm even quicker than some of the predictions I put up there. And one of the scary things is that this feedback loop is not very well understood by the scientists. It's not very well incorporated into the climate models yet. And so when you see some of the IPCC predictions, you have to understand that some of these negative and potentially more catastrophic feedback loops have not actually been incorporated. So that's one of the big worries, that especially that the warming we're experiencing is already so dramatic in Alaska and the northern latitudes.
My question is, how can we begin to talk about climate change without talking about the war and the effect of the military-industrial complex? And also, I guess a side question would be, what effect does a bomb drop manufactured by Lockheed Martin have on the environment? Does that create a bad situation for the environment, war and bombs exploding? We've seen depleted uranium in Lebanon and Israel, also Kosovo from the war we had in the early 90s. So if you could talk about...
war is an environmental disaster. There's no question of that. One of the big legacies, for example, of the first Iraq War, huge environmental problems there. But I'll tell you, if we don't get this climate change thing under control, Anna was talking about the roof of the world, you know, the Himalayas and all that, that water system anchors the drinking water for 1 billion people. In the Andes, there are glaciers that provide drinking water for tens, if not hundreds of millions of people. The increased sea level rise, the potential for refugees, fighting between nations over scarce resources, the international security implications of this problem, I would argue, they might not feel as immediate as some of the things that we're seeing today, but I would argue that the national security implications of this issue really dwarf anything that we're seeing today.